Good afternoon, dear colleagues and guests. We start our session, and first of all, I have to explain to you our agenda. Today, at our meeting of the Dissertation Council, our candidate Vasilkov Sergei Andreevich for the candidate degree of Physical and Mathematical Sciences on Speciality 010413 Electrophysics, Electrophysical Installations. And the topic of the thesis is Structure and Properties of Electrohydrodynamic Flows Caused by the Wien Effect. And me, Timofeev Nikolai Alexandrovich, Doctor of Physical and Mathematical Sciences, Professor, was appointed the Chairman of our Thesis Council. And please allow me to introduce my fellow board members. Klucherov Andrei, Doctor of Physical and Mathematical Sciences, Associate Professor, Professor of the Department of Optics of St. Petersburg State University. Yerin Konstantin Valerievich, Doctor of Physical and Mathematical Sciences, Professor, Professor of the Department of General and Theoretical Physics of North Caucasian Federal University. Korabenikov Sergei Mironovich, Doctor of Physical and Mathematical Sciences, Professor, Head of the Department of Place Safety of the University of Novosibirsk. Mode, Professor James Cotton, the University of McMaster, Canada. And also we have our candidate, Doctor of Mathematical Science, Professor of the Department of Physics of St. Petersburg State University, Stishkov Yuri Konstantinovich. First, I would like to emphasize that according to the federal law about science and state scientific and technical policy, St. Petersburg State University has the right to independently award academic degrees. And the corresponding order on the procedure for awarding academic degrees was issued at St. Petersburg State University. And in accordance with this order, the meeting of the Dissertation Council is considered eligible if at least 2/3 of the approved membership of the Dissertation Council takes part in its work, but not less than 4 persons. Our Thesis Council has 5 members, including James Cotton, who works in the remote interactive mode, and audio and visual contact is provided with him. The procedure of today's meeting of the Dissertation Board, with a total duration of no more than 2 hours, is the following. Yesterday we had a meeting, and we and the chairman's summary report on the main content of the document submitted by the candidate and their compliance with the established requirements. A brief report of the candidate for the degree reflecting the main points of his research. 3 questions to the candidate strictly according to his report, and responses of the candidate. The speeches of all the members of the Thesis Council by turns, with reviews, with a statement of their positions, with questions and suggestions to the candidate. Number 5, the speech of the chairman with his review. Number 6, the answers of the candidate for the degree to the questions and remarks of the members of the Dissertation Council, no more than 15 minutes. But I think that, according to the tradition, the candidate's report was usually 20 minutes, and you are not pressed for time. Please take your time. Number 7, open discussion. Speeches at the request of those present at the defense of the thesis, with a brief presentation of their positions and with specific questions and proposals on the topic of research. All interested persons are required illustration sheet Number 8, final answers of the applicant. The speech of the scientific supervisor. A 5-minute break before an open vote in order to make a conclusion on the issue of awarding or not awarding the academic degree to the candidate, and open individual voting, counting of votes by the chairman of the dissertational council with entering the results in the minutes of the meeting. Then decision on awarding or not awarding the academic degree, and the final word of the applicant. Before switching to the realization of the meeting's rules of the procedure, I remind you to switch off your mobile phones. Thank you for your attention. I also inform you that an audio and video recording of our meeting is being conducted on the website of St. Petersburg State University, and simultaneous interpretation of speeches from Russian into English or from English into Russian is also provided. Now, Chairman's summary report. The thesis of Vasilkov Sergei Andreevich for the candidate degree of Physical and Mathematical Sciences on Specialization 010413 Electrophysics, Electrophysical Installations on the topic Structure and Properties of the Electrohydrodynamic Flows Caused by the Wien Effect was accepted for the defense by the order of the Scientific Secretary from the 5th of December 2019. The thesis council was approved by the order of the Scientific Secretary on the 5th of December 2019, and our candidate submitted the following documents to the Scientific Secretary. First, an application form addressed to the Rector of St. Petersburg State University, the corresponding member of the Russian Academy of Science, Professor Kropochev, about the acceptance for consideration and defense of the thesis, which was submitted on the 30th of September 2019. The review of the scientific supervisor, Mr. Stishkov, professor of the Department of Radiophysics of St. Petersburg State University, and a list of publications containing 6 works. All these works are indexes in Web of Science and Scopus. Number 4, the certificate about candidate exams issued by St. Petersburg State University certifying that our candidate successfully passed candidate exams on Specialization 030601 Physics and Astronomy, the History and Philosophy of Science. Excellent. The English language, excellent. Electrical physics, excellent. The diploma, master's diploma with honors, issued on the 15th of July 2016. It certifies that our candidate received master's qualification on the main educational program, Applied Physics and Mathematics. The thesis is done in Russian and English, both in paper-based version as a manuscript and in the electronic form. The thesis is designed in accordance with the requirements of national state standards. It should be noted that all listed documents comply with paragraph 12 of section 3, presentation and defense of dissertations procedure for awarding academic degrees at St. Petersburg State University. That's all for now. Do you have any questions? No questions. Thank you very much. And now, a brief report of our candidate. Thank you very much. Distinguished chairman, distinguished board members, distinguished guests, let me introduce my report on the results of my thesis on the topic the structure and properties of electrohydrodynamic flows caused by the Wien effect. The first of all, a few words concerning terminology. In my work, the Wien effect in liquid dielectrics is considered. Max Wien experimentally discovered violations of Ohm's law in electrolytes in strong fields, and this effect began to bear his name. Moreover, In strong and weak electrolytes, the effect is explained in different ways. In strong electrolytes, the first Wien effect, there is an increase in ion mobility. The second Wien effect occurs in weak electrolytes, was explained by Lars and Zagar as an increase in the intensity of dissociation of ion pairs. Since liquid dielectrics are considered weak electrolytes, it is precisely the second Wien effect that will be discussed in my work. This effect is also found in the literature as an Onsager effect or simply as an electric field amplification dissociation. Further, I will call it simply the Wien effect. In inhomogeneous electric fields, the Wien effect leads to the formation of an uncompensated electric charge on which the Coulomb force acts, and an electrohydrodynamic flow occurs. There are several more mechanisms of electric charge formation in liquid dielectrics. Below, they are presented for the case when the liquid in single phase, homogeneous, isothermal and incompressible. This is an injection of ions from the surface of an electrode. These are non-equilibrium layers of ion deficiency. They are formed if there is no injection and the liquid has its own conductivity. The Wien effect is the object of my study. It is in homogeneous fields. The ion concentrations are also inhomogeneous and their partial separation occurs. A charge is induced in the volume of the liquid. The Wien effect has a theoretical description and can easily be taken into account in a computer model. It is also expected an EHD flows of this type, the stability of it. There is a problem. This effect was poorly studied in the framework of electrohydrodynamics. Therefore, the goal of my work was to partially close this gap, to systematically study the Wien effect as a mechanism for the formation of an electric charge and the occurrence of electrohydrodynamic flows. It was necessary to study the structure of such sections, to verify the applicability of the theoretical description for computer simulation, and also to reveal the role of this effect in the presence of other mechanisms of charge formation, namely injection. The research results in my presentation are presented in the following order. First, the results of computer modeling are analyzed, then this two experimental studies. Current voltage characteristics and velocity fields are measured and they are compared with the calculation results. The following system of equations is used to describe EHD phenomena. This is the Poisson equation, which describes the distribution of electric potential. This transport equation for ion concentration it is the Nernst-Planck equation and the equation of hydrodynamic, the Navier-Stokes equation. The source function in the Nernst-Planck equation describes dissociation and recombination. The Wien effect is precisely here taken into account using the factor F, which according to Onsager's theory is written as follows. In weak fields, this is practically unity, but when the field strength reaches 10 in the 7th volt per meter, a sharp increase begins. To begin with, we consider a fairly often studied system of electrodes. This is a metal plate. I will call it a blade above the plane. The voltage is 30 kilovolts and the liquid is a mixture of transformer oil and cyclohexanol. and depending on the percentage of the additive, various values of low voltage conductivity were obtained. Now we consider an intermediate value of 10 volts 9. Here is a computer model. It is the simulation. The Wien effect is taken into account, but the injection from the electrode surface is not taken into account. The electrode does not deliver ions to the liquid. Here are the simulation results. Field strength and enhanced dissociation. The electric field almost reaches 2 in 10 to 7 volts per meter, which corresponds to tenths of times the intensification of dissociation. In this region, an increase of ion concentration occurs and the electroneutrality of the liquid is disrupted. And the charge structure is as follows. There is a thin layer of ion deficiency, negative charge around the positive electrode, and behind it, due to the Wien effect, a region of positive charge is formed. The force, Coulomb force, acting on the negative charge, presses it to the surface of the electrode and does not lead to the formation of a flow. The flow is formed due to the action of a force on a positive charge. Here, the force is directed downward, respectively. The fluid moves from the blade, and flow occurs with the following structure. The flow changes the distribution of ion concentrations and space charge. Such intensities, tens of centimeters per second, and the direction of flow are also observed with the injection mechanism of charge formation. These are two fundamentally different mechanisms, but their manifestations are similar in such a system they simply cannot be isolated from each other. Therefore, for an experimental study of the Wien effect, a fundamentally different system was considered, where a strong inhomogeneous field was created using a dielectric barrier. Let us first consider one-dimensional problem. Where the non-conducting barrier between the electrodes in a fluid with a finite conductivity. As stationary distributions are of interest, this problem should be interpreted as the problem of current flow through a medium with different conductivities. It is necessary to take into account the law of conservation of charge. The barrier conductivity is equal to 0, then the current density is 0 here. Therefore, in the stationary case, the field in the liquid becomes 0. As I have already mentioned, if the density of the electric field is equal to 0, and if there is a charge on the surface of the barrier, which will preserve the necessary amount of liquid, and if there is a hole in the barrier, then only the normal component of the field becomes 0, and the tension lines are pulled into the hole. Here a strong field appears, the Wien effect appears, and a flow arises that can be investigated. There is no injection, since the hole is far from the electrodes. For this system, the main results we obtain. Injection is impossible here. There is no injection surface. The applicability of the boundary condition was separately verified. It turned out that in this system it is guaranteed to be applicable for conductivity greater or equal to 10 or 8. And before describing the flow in such system, let us consider simpler geometry. A plate with a rounded radius with one radius of curvature mounted between the two electrodes, and let us consider the results near the end of the plate in the region of interest. And similar Graphs are presented here, field strength and enhanced dissociation. The maximum values are also observed at the end, but the course of the field lines of force is completely different here. They go along the dielectric, so the separation of charges occurs in a different way. Along the surface, a region of negative charge is formed from above and a positive charge from below. They are affected by the Coulomb force, which is directed along the surface of the barrier, and we observe two streams that propagate along the surface of the dielectric. This result is generalized to any edge of the barrier or angle. That's why when we return to the correlation system, we see the following thing. There are two characteristic scales, the entire whole and a separate angle. And on two scales, there is a separation of charge. And the greatest force acts at the edges of the barrier, so it turns out that the fluid flows are the following. From the edge of the hole, there is a stream along the barrier along its surface, and a small stream inside the hole is also observed. And in the outer zone, it turns out to be that the flow is the following. The liquid flows to the hole and then radially spreads along the barrier. And it was experimentally investigated to directly verify the applicability of Onsager's theory. And to register the EHD flow, we use the method of laser anemometry using particle images, or the PIV method. The method consists in registering images of the visualizing particles and subsequent statistical processing from where the velocity field is located. The current voltage characteristic was also measured in the system. It is this comparison of experimental and calculated data for a system with a dielectric barrier. Here is a comparison of the current voltage characteristics for the two conductivities. The experimental and calculated dependencies are non-linear. They are in relatively good agreement, but the experimental data deviate towards lower values at high voltages by about 20%. It is most interesting to consider velocity fields. This slide shows the area above the hole, the contours of the velocity module, these are colored lines, and the fluid flow lines, black lines, are shown. On the left, there is a simulation. On the right, there is an experiment. Voltage is 10 kilovolts. It can be seen that although the flow structure coincides, there are noticeable differences quantitatively. At the same time, the speeds are quite small, fractions of a millimeter per second. As voltage increases, speed increases and compliance improves. This voltage is 30 kilovolts. Visually, the distributions are very similar. To quantify the discrepancies, we consider a point of 3 millimeters above the barrier and construct the dependence of velocity on voltage. Here we see that with increasing voltage, the discrepancy decreases from several times to about 10%. The speed changes by 2 orders of magnitude. It turns out to be that with such accuracy we can trust the simulation which used on Sergei's theories to calculate electrodynamic flows. And now with this result we can return to the blade plane system and answer the question due to which mechanism of charge formation EHD flows arise, due to ejection or due to the Wien effect. For this study, we organized the following thing. An experiment was conducted and computer simulation was carried out, where only the Wien effect was taken into account. The results were compared. If the velocity fields and currents coincide, then it turns out that taking into account the Wien effect is sufficient to describe them. If not, the injection charge generation must be taken into account. Again, let us consider the results. Let us start with current voltage characteristics. The fluid conductivity increases. For minimal conductivity, the calculated black curve of the experimental red and blue curves are very different, and they are different at different polarities. Injection charge formation clearly dominates here. With the increase of conductivity, the discrepancies decrease and then practically disappear at a conductivity of 10 or 8. To describe these current voltage characteristics in the model, it is sufficient to take into account only Wien effect. And similar trend is also observed when considering velocity fields. Here we see the dependence of the maximum current velocity on conductivity. Points are experimental data, curves are calculation results. If the conductivity of the liquid is still not large enough, the experimental and calculated data differ. In this case, it is necessary to take into account both the injection and the Wien effect. At maximum conductivity, the flows coincide in the intensity and structure. That is again here to describe the EHD flow, and it is sufficient to take into account only the Wien effect. Those charge formation due to the Wien effect begins to prevail in relatively conductive liquids. Summing up all of the above, we can formulate the following provisions to be defended. It has been experimentally shown that the Wien effect is an objectively existing charge formation mechanism in liquid dielectrics, which leads to EHD flows of the same intensity as other charge formation mechanisms. With an increase in the low voltage conductivity of a liquid dielectric, the dominant charge formation mechanism changes from injection to mechanism due to the Wien effect. Number two, the results of the numerical calculation of EHD flows caused by the Wien effect using Untitled theory are sufficient agreement with experimental data. Number three, it was the structure of EHD flows was described caused by Wien effect. Only at the surface of the electrode, in this case, two streams of EHD flows are formed along the surface of dielectric. Thank you very much for your attention. Sergei Andreevich, thank you very much. Your questions, please. You have a questions, Vadim Mironovich? I have got several questions. What is dissociated in your research? Ion pairs, I mean, what is the nature of these ion pairs? Chemical composition of these ions, we know this chemical composition, but the matter is that for Untitled theory it is not important. The size of ions should be smaller than the distance between ions in ion pair. Untitled takes into account the size of ions. This constant is included. The electrical permeability, the size of ions are taken into account. Did you take into account these factors? It is included in this theory. Just in a second. This is the right slide. As a result, you see this variable has dielectric permeability, temperature, and field intensity, the size of ions is not taken into account. Here, if we consider dissociation, the size of ions should be taken into account. You mentioned that the layers, slide 8, counter-charge layer is formed near the electrode. In your dissociation effect, there should be the layer of counter-charge, but why do you use it into the in this dissociation? You're right.
I'm sorry, I've lost audio.
This question is remark in my review. I would like to specify. You try to answer this question. I would like to precise specify something. Slide number 9, where you study the distribution of the fields according to the situation where you had the dielectric barrier with the hole between electrode and the normal component of the voltage of the field. You have a special plate. A normal component is equal to 0, and judging from your picture, on the surface of the glass, the induced charges from the liquid, there should be electric field inside, but you states that such condition is applicable only in case of high conductivity, more than 10 minus 8 Siemens per meter. But if we compare with current voltage characteristics on slide 22, we see that from all your samples, only one sample meets the requirements. 0.8 to 10 minus 8. Isn't it a contradiction when you use the condition which could not be met? The matter is that the test of the applicability of this boundary condition was with the help of computer simulation, but we did not take into account Wien effects. When we consider real system, there is an increased dissociation, and it means the increased conductivity up to 10 minus 8 or even more. But here you have experimental results. This is the experiment, but the conductivity, no voice in the microphone. Slide 22. Do you mean this slide? It is the system blade plane. Here we don't consider barriers, and this question is out of place about flows. Thank you very much. Any other questions? Professor Cotton, do you have any questions to Sergei? Do you have any questions to Sergei? Do you have any questions?
Yes, I do. Sorry, I was on mute. Thank you. Can
Do
you
you
hear me
have
now?
any questions to Sergei?
Yes, can you hear me now?
Mr. Cotton, do you have any questions to our candidate?
Can you hear me?
Please ask questions.
Okay. So first off, thank you very much.
Большое спасибо.
Okay, I enjoyed reading the thesis.
Мне очень понравилась диссертация, ваше исследование.
I have several questions.
У меня есть несколько вопросов,
regarding the
которые касаются ваших исследований, результатов ваших исследований.
Is regarding the use of PIV system.
И вопрос касается использования системы PIV. Другими словами, метод визуализации движения микрочастиц.
Of the material used.
Какой материал был использован в ваших исследованиях?
How that was selected. And
что было выбрано? Надень наушники. Наденьте наушники, наденьте. Наушники, наденьте наушники. Professor Cotton, please repeat or rephrase your question because there was some poor connection. Please repeat your question.
I'm going to start. I'm very interested.
Большое спасибо за ваше исследование. Мне очень понравилось читать вашу диссертацию. Я был доволен вашими результатами. Меня интересует метод визуализации движения микрочастиц, PIV метод. Могли ли бы вы его пояснить более подробно? Какие инструменты вы использовали для исследования и так далее?
So, the key element of the PIV facility.
Да, ключевой элемент исследования с помощью метода PIV. Пусть он оденет наушники. PIV method.
Yes. So, what is the dielectric constant difference between the fluid?
Какая диэлектрическая постоянная в жидкостях?
And the particles, and did that have an effect on the system?
I have a special slide to answer your questions concerning dielectric permeability and particles. This is the slide. As for dielectric permeabilities in liquids, it is 3. And particles, it is a very complex object. It is glass and gas. Here I evaluate dielectric force which affects this simplified particle when we consider only dielectrical ball. And this velocity is very low in comparison to EHD flows.
So this is the velocity you have right now in comparison.
Это скорость, которая у вас вот сейчас при исследовании по сравнению с эффектом Вина.
So what flows are you comparing it to?
Какие течения вы сравниваете?
In the high field range or the low field range?
В каких в низких напряжениях или в высоких? In the field of high voltage.
Okay. So I'm curious whether or not you did a similar comparison to the low voltage range, if that would.
Почему вы не сравниваете поля с низким напряжением? Почему вы их не рассматриваете? And if we shift from 30 kilovolts to 10 kilovolts, the voltage of the field becomes 3 times lower, and correspondingly 10 times the velocity and force will be lower. And at the same time, it is the evaluation. I neglected gas bubble, and the scale of the hole, the size of the hole was studied. And because the evaluation of the velocity should be lower, should be less, and the density of the dielectric oil is 20 times higher than water.
The density is of the oil 20 times higher? No.
Разве viscosity of the oil?
Okay, viscosity. Okay, I thought you said density. Okay, I think I'm not sure if I saw that in the thesis, but I think that would be important to include in the thesis.
Не увидела этот ответ в диссертации, но мне кажется, очень важно в дальнейшем включить это в результаты вашего исследования. Yes, right, you are. It was only the answer to your review.
Thank you very much. I wasn't sure you would have my review. So, you know
Спасибо большое за ответ. Я удовлетворен вашим ответом.
So my next question is around the CFD modeling side.
И следующий мой вопрос касается моделирования.
And I think I'm curious as to the manipulation of the diffusion coefficient.
И здесь меня интересует коэффициент диффузии.
Thank you. So you mentioned that
Вы упомянули, что
validated the results throughout the thesis.
Что в результатах исследования Please repeat your question again. Repeat your question again.
So on page PDF page 43 of your thesis.
Страница 43 вашей диссертации.
You had argued that
вы говорите,
Peclet number is less than 1, that it's usually
что
stable.
Величина меньше единицы, и она, в принципе, стабильна.
However, in some cases you needed to heighten, you mentioned, which I assume you...
Но в некоторых случаях вы использовали завышенные коэффициенты. Yes, I used exaggerated coefficients in my study. In this system of blade plane, in this case, let me explain to you this slide.
Thank you.
This is the coefficient in this formula, which did not exceed 100 in my calculations. In order to check my calculations, I considered bigger exaggerations, 1,000 times exaggeration. And here are the results of the simulation of the modeling, and you can see that the difference in the maximum velocities of speeds of flows is no more than 1%. And here I can conclude, from this I can conclude that the results of the modeling are not sensible to the diffusion coefficient. And that's why I can use exaggerated diffusion coefficient 100 times exaggeration.
So when did you? It sounded like you had to do it only sometimes. You had to.
Вы сказали, что вы только иногда вот так завышали.
Can you explain what those situations were?
И можете пояснить, когда именно вы использовали завышенный коэффициент? These are the situations when I calculated the system blade plane. There is a very small curve radius in the blade, and there is a very large gradient. And so that's why the exaggeration is not stable. But for this, I tested this system, and on the whole, I am sure that it is applicable.
Okay. No, that's good. So
Да.
thank you for addressing that.
Спасибо за ответ на мой вопрос.
So my next question is
И
a little
еще вопрос у меня есть.
bit different. I'm curious as to your criterion for transition.
И ваши критерии для переходов. Какие вы критерии использовали?
In your particular case, you used
В вашем
conductivity
случае вы использовали такой критерий, как проводимость.
from charge injection to Wien effect.
Из инжекции или заряда к эффекту Вина.
Do you think that there's? I think it's probably very geometry sensitive.
Конечно, это очень геометрически чувствительный момент.
Can you think of a dimensionless ratio that you could develop or think of that would give you an idea of this transition?
И что вы можете сказать вот об этих переходах? Thank you very much for your question. These are the results for the specific system, and on the whole, Such transition can be expected for other geometries. The range of conductivity where we see the transition will be shifted to one or other side slightly. And the non-sized criteria, limitless criteria, is a subject of my further research. Some mobility aspects, not only conductivity, should be taken into account, but it is the subject of my further research.
Okay. Thank you very much. And I just have one small question or comment, maybe.
Еще один момент.
The flow is modeled as laminar flow because you were using COMSOL.
Вы использовали консоль, модель и ламинарность. Yes, laminar flows were calculated.
Yeah. So generally they're laminar, but in some areas you had very high velocities.
И ламинарные течения имеют очень большую скорость, правильно же?
Is there any concern about local effects of turbulence? I think laminar.
И вы не беспокойтесь о какой-то турбулентности, связанной с этим и так далее. When I calculated it, there was up to 100. Liquid is very viscous, as you may see, and in our case, we should not expect turbulence.
So I think maybe you could just mention it to laminar model because that wasn't.
И, конечно, вот на мой взгляд, ламинарная модель должна быть объяснена в вашем исследовании.
So that's more of a comment because I was sure it was laminar.
Просто
rule out any,
это как-то бы украсило ваше исследование.
And my last question is a little bit more generic.
И общий вопрос, последний вопрос, вопрос общего характера.
I think in your literature review you very clearly mentioned that
что
it's not included in many studies.
Что касается литературного обзора, вы говорите, что во многих исследованиях эффект Вина не принимался во внимание. Yes, right you are. Wien effect was poorly studied in many literary sources.
And your own work shows that they can have an additive effect, or in some cases maybe.
И в вашей работе вот говорится, что эффект Вина это некий дополнительный эффект или что это? It is a true mechanism of the charge formation. In some cases, it is of low importance and can be neglected. For example, in liquids with low conductivity, with poor conductivity, but in liquids in high conductivity, 10 minus 8, for example, as my research shows, Wien effect is prevailing mechanism in different situations.
I agree 100%. It would be interesting.
И я на 100% с вами согласен.
With your research, is developing that criterion to help us understand past.
И, конечно, я уверен, что ваше исследование внесет большой вклад в эту область и поможет нам проводить дальнейшие исследования в этой области. Yes, I think so.
I don't have any more questions, but thank you.
У меня больше нет вопросов, и мне было очень интересно читать вашу диссертацию. Thank you very much. Are there any other questions? Sergei Andreevich, I have a simple question. You use dielectric oil as a liquid, and what kind of oil was it, and the repetition of experimental results. What parameters of your liquid were important? How did you measure it and control it? We studied the mixture of dielectric oil and cyclohexanol. It was interesting in order to register the field of velocities. And first of all, it is necessary to preserve the stability of liquid conductivity. When we worked with other liquids, butanol, for example, we observed the changes of conductivity, and for us we could not understand how to control the results. Also, we tried to study the mixture of vegetable oil and cyclohexanol, and we received a very interesting effect, but everything wasn't suitable. Are there any other questions? If you don't have questions, we turn to the other point of our agenda. There are no external reviews, and now let us hear the reviews of from our board members. And first of all, I would like to give the floor to Mr. Klucherov. I am not going to read out my review. It seemed to me that in this the work does not consider the additive which bears ions, mobility and other things. They can't but influence the diffusion process on the one hand. But on the other hand, I heard the speech of our candidate several times at the conferences, and my impression was the following: the topic is very actual, and it can make the contribution into the science. And the most important thing, but the approach which was used by our candidate is very interesting, and I liked this approach because today there are a lot of serious processes on the earth, in the world, which are neglected, and they are waiting to be solved. For example, the process of failures in satellite connection at the moments of the increased solar activity. And it seems to me that the things and conclusions which our candidate made, they can be useful while analyzing such kind of processes. And that's all what I wanted to tell you. Yes, and to add, of course, it's a pity that ionization process, which gives birth to ions, was taken for granted. I'm sure that there are a lot of interesting things which are connected with this process and should be studied. Andrei Nikolaevich, your conclusion, whether this work deserves the candidate degree. Of course, the work is very successful. In some, of course, it is not deprived of remarks, but the work is very interesting. The results are very useful, and I approve this study. You don't have any questions to our candidate, do you? Maybe you would like to comment upon the brief report of our candidate. I agree with my candidate. Thank you very much, Konstantin Valerievich. Nikolai Alexandrovich, thank you very much. I would like to follow the tradition. Of course, the topic of our candidate is very actual. Electrohydrodynamic technologies are in this shade in comparison to electrostatical. If you speak about jet printers or other system of electrical membrane technologies which are applied, they are prospective. There are a lot of monographs and reviews in many serious journals which are devoted on hydrodynamic processes. The author of such reviews thinks that the processes of ion conductivity play a crucial role in electrohydrodynamical processes, and the task of our candidate concerning the second Wien effect, its influence on electrohydrodynamic in the oil with the additives, make this work actual. On the whole, the work is very impressive. It is a classical modern study which combines the qualitative experiment, successful experiment. It combines computer modeling. It has become the trend today in such kind of studies. The work has a theoretical part which describes mathematical model which is used by our candidate. There are interesting ideas. One of the most interesting findings of our author is the way to separate the injection processes near electrodes and the influence of increased voltage of electric field on the concentration of charge barriers. I mean the plate with the hole between the electrodes of the cell. But here there are some questions concerning this technology. As for my remarks, I formulated several remarks. One of them was mentioned by me, but I did not quite understand how if we place dielectric plates inside, outside, we have the electric field. There are some things which were not very well explained by our candidate. But if the surface charge is inhomogeneous along the surface plate surface. And one more remark of discussion character in a range of modern reviews on electrohydrodynamic processes such as Anatoly Zhakin. There is an information that in liquid dielectrics some unbalanced layers play a crucial role. The correlation between the mobility, conductivity and dielectric constants of the matter, and the sizes of the layers up to tenths or hundredths of millimeter, and you used them in your experiments. It would be interesting to know whether such layers influence the processes you observed in your study, and some remarks concerning the design of your dissertation. In the slides, on the whole, the thesis conforms with the requirements, and our candidate deserves the degree of the candidate of physical and mathematical sciences on specialty electrophysics, electrophysical installations. Konstantin Vladimirovich, thank you very much. Sergei Andreevich, please answer the question. And when the barrier accumulates the charge, a strong electric field is created inside, as in a capacitor. In my case, there is a voltage of 10 to 7 volts per meter, and when considering the simultaneous results in the barrier area, nothing was displayed since there were no calculations. In fact, the field should be strong there. Did I explain everything? Are you satisfied with my answer? Please, Sergei Andreevich, answer all the questions. As for non-equilibrium layers, the size of these layers depends on the conductivity of the liquid and on the field strength. In a system with a dielectric barrier, the intensity of the normal component was 0. Therefore, there is no layer either, but if the condition En equals 0, it is not fulfilled. Then it will appear. If we consider the surface of the electrode, then in the absence of injection, such a layer is present. It adjoins the surface, and the charge formation due to Wien effect occurs already behind it. And in the systems considered in the work, I paid attention primarily to the Wien effect. The role of these layers is large. Flows of a different type arise. And electrodes present these layers, you see, on the surface of the electrode. At the account of Wien effect, the charges appear behind them, behind the electrodes. Konstantin Valerievich, are you satisfied? Sergei Alexandrovich, thank you very much. I am satisfied with your answers, but when you write normal component of voltage equals to 0, of intensity equals to 0, I can't understand what you mean. But let us discuss it later, whether there is a field or not. How the distribution looks like there, concerning the charge and field. In liquid, the normal component of the field equals to 0, but when we reach the barrier, the intensity of the field increases greatly, and then within the barrier there is a high intensity of the field, but in the study this layer is considered as a surface charge. It is hidden in the model, and there is a nice shift because the surface is charged from the 0 to higher figures, and the model is one story and physics is another story. Konstantin Valerievich, Sergei Mironovich, the floor is yours. Let me speak about the actuality and mention my remarks. the question of dissociation mechanism, of the appearance of electrohydrodynamic flows has long been studied. I discussed it with Professor Yagovt. He invented some EHD installation on the orbit in the outer space, but this installation in the end was out of work, and he wanted to launch some dissociation mechanism, some injection mechanism, and I was greatly impressed by his idea, and it is pleasant to see that this problem was solved in your study. And computer model which was created, it was created without any adjustable parameters. It is very important, and our historian theoretician stated that the value of theory is defined by the difference between the number of forecasts for this theory and the number of admittance which were made by this theory. And such commonality of 10 or 20%, it is brilliant. And as for my remarks, the first remark was heard in your brief report that classical first Wien effect. The second Wien effect, I wasn't familiar with this effect. I consider it as Unsager effect. And it would be better to use Unsager effect instead, because it is obvious. The second remark, as for the provision for the defense, you mentioned that when the conductivity increases, the transition from injection to dissociation mechanisms occur when specific electrical conductivity exists. But here you should be focused on the type of additives, and they are not mentioned in your study. What are you going to add? It seems to me that the transition can occur with different, for example, non-injection electrode and other dissociation additive will lead to the appearance of dissociation mechanism. Number 3. About electrostrictive member, my question. This member in the equation can be neglected because the liquid can be condensed. The processes, the velocity of the processes is much lower than the velocity of the sound, and such electrostrictive balance will be automatically set, and in this respect it can be neglected. I have got 3 remarks. And the main conclusion, I think that the thesis is very successful. It conforms with the requirements, and the level of our candidate is very high, and we can consider him the candidate of physical and mathematical sciences of our St. Petersburg State University. Sergei Mironovich, thank you very much. Professor Cotton, please, your review. Professor Cotton, the floor is yours. The floor is yours, Mr. Cotton.
Thank you very much.
Mr. Cotton, the floor is yours.
Thank you. Can you hear me now?
Вы меня слышите?
Okay. I think overall,
Я хочу сказать,
very well done.
что диссертация очень успешно выполнена. Она посвящена компьютерному моделированию и экспериментальному исследованию электрогидродинамических течений в диэлектрической среде.
I believe there's original contributions both on
И наш кандидат сделал вклад в область исследований.
And I very much appreciate the novel approach to the experimental
И мне очень понравился этот новый подход нашего кандидата к экспериментам, который он провел.
I think the use of PIV was interesting, although
И я считаю, что очень интересно было использовать метод PIV, метод визуализации движения микрочастиц.
That you have to be very, very careful with PIV in certain situations, and it's been shown that the particles can influence the electric field and the flow in some cases.
И
you've seen that here at McMaster.
Кажется, что в исследовании умело сочетается компьютерная симуляция дистрибуции пространственного заряда, вызванной эффектом Вина, и последующего эффекта на ЭГД течения.
I think in general your justification was
И
good.
Сочетая экспериментальные и численные результаты, кандидат определил применимость теории Ангейзера через сравнение структуры течений и вольтамперных характеристик системы. И результаты исследования могут прямо использоваться в ряде технических разработок.
In particular, the effect of the dielectric constant difference, the effect of the borosilicate geometry being hollow,
и
the effect on
работа актуально имеет научную новизну. Речь идет о математических моделях, которые описывают ЭГД-явления, включая ЭГД, объемную силу, заряд, инжекцию, диссоциацию, теорию рекомбинации. И я понял, что вы использовали предыдущие исследования, вы основывались на предыдущих исследованиях в вашем исследовании.
Overall, this could be expanded in your thesis.
Но, конечно, можно было несколько расширить ваши наблюдения, ваши исследования, ваши диссертации.
What I enjoyed the most, on the other hand, was that if we can
Что мне понравилось,
you will be able to create EHD type pumps.
Что на основе ваших исследований
and then eliminate some of the degradation effects we see with charge injection.
И можно с помощью ваших исследований можно устранить эффекты деградации в течениях.
And I think you could expand your geometry to create novel flow geometries that can be used for heat transfer applications.
И также можно создать новую геометрию, которая будет использоваться в дальнейшем.
So in summary, I believe that the contributions
уверен, что результаты вашего исследования вносят неоспоримый вклад в науку.
And your excellent journal publications as well. I have not mentioned that.
И, конечно, я не упомянул, что результаты вашего исследования опубликованы в международных научных журналах. Это немаловажно.
And I believe that your work provides the rigor and the appreciation for a wider field of study.
И, конечно, ваша работа это основа для дальнейших исследований в этой области.
And the scientific contributions are relevant to specialization.
И ваш научный вклад отвечает всем требованиям специальности. Большое вам спасибо. Диссертация заслуживает присуждения искомой степени. Пожалуйста, ответьте на... Sergei, please answer the questions of our board members. I have got a comment on the stability. It is one of the interesting directions in such studies, and I didn't have time to launch this system. And if we understand that such flows are stable at the account of Wien effect, it is excellent, but we will conduct further research in order to understand this and figure it out. Professor Cotton, are you satisfied with the answer of our candidate?
I am overall, yes.
Да, я полностью удовлетворен. And now my review. For me, it is easier to speak because nearly everything has already been mentioned by my colleagues. Two moments. The first, I liked most of all in the work, and the second, the remark. My experience of work in the thesis councils, the work which widely uses computer modeling has successful results, but the author can't explain these results because computer program is an independent system, software, and in this case our candidate simulated many things with the help of computer software. And the second moment I would like to focus on, highlight, I have not seen the candidate DCT, any candidate or doctoral thesis which would be written so brilliantly, because in this work I did not see any spelling mistakes, misprints. The language is fluent, and I would like to highlight this fact. And now, small remark. In the system with the hole in the dielectric barrier, in plate electrodes, current voltage characteristic deviates 20%, but for this system with electrodes blades, we can't see such deviation. And in this system with the electric barrier, there are some deviations. How can you explain the different extent of numerical correlation in these two systems? You did not mention it in your work. And my remarks don't spoil the advantages of the work, and the candidate deserves the degree of the candidate of physical and mathematical sciences on speciality 01 or 413 electrophysics, electrophysical installations. Thank you very much. Please answer my remark. Thank you for your remark. I have to comment this different character of the numerical data, but the main is the fact that when we consider the system with the blade, we have some influence from injection, and it compensates this small deviation down. If we consider the flow caused by Wien effect, the currents would have lower velocity, but these 10% are defined by the injection, and it increases such figures, and we see the coincidence of the data. In my further research, we will compare everything and answer your question in detail. Distinguished colleagues, guests, are there any volunteers who want to have the floor? Maybe you have some questions towards our candidates. Yuri Konstantinovich, scientific supervisor, please, the floor is yours. Today, the work which was written within 10 years. It took our candidate 10 years to write this dissertation, and at the first conference in Slovenia, he was this bachelor student, and within this period of the time he progressed. It is a real, completed, qualified scholar with a world name. And at first it seems very simple. You study the flow and understand that this flow can't be separated into with the help of the injection effect and Wien type. But this hole in the dielectric barrier, it is a very peculiar thing, and this hole can give the flow. And I would like to call this the effect of Vasilkov, and because no one could believe that such flows existed, but in fact they should be explained not by Wien effect. They should be explained by Untitled theory, because this theory accurately describes this effect. But we should take into account the fact that in the laboratory conditions it is impossible to create the hole with a diameter of 1 millimeter with the edges which define the effect with the help of the specific models, and this divergence is caused, this discrepancy is caused by this fact. I would like to say that when I worked with Sergei, I was greatly satisfied. He is a brilliant lecturer, and when he was a postgraduate student, he was my assistant. He delivered lectures together with me. He is a completed scholar, and he is we are proud of him. Our St. Petersburg State University is proud of him. Yuri Konstantinovich, thank you very much. It's time to discuss the results of the brief report of the candidates, the work of the board members, and please, I ask you to leave the hall. Non-board members, please leave the hall. I will invite you when our consultation meeting is over. The Thesis Council discussed the report and the quality of work of Sergei Andreevich, and the meeting continues. I raise the question of awarding an academic degree to an open roll call, whether to award our candidate with the degree. Andrei Nikolaevich, your opinion? Yes, I'm for. I'm for. Yes, I'm for. Konstantin Valerievich, your opinion? Yes. Sergei Mironovich, Professor Cotton?
Yes.
Я за голосую. And my opinion is the same. I'm for the degree of the candidate of physical and mathematical sciences to Sergei Andreevich Vasilkov. Sergei Andreevich, I congratulate you with the degree of the candidate of physical and mathematical sciences. Sergei Andreevich, your final words. I would like to express my gratitude to the Thesis Council. It is great that you took part in this defense procedure. I would like to express my gratitude to my scientific supervisor, Vladimir Cherkov, who was my scientific supervisor when I was a master student. We discussed a lot this research, and also Vladimir, thank you very much for the help with the organization, and of course Natalia Vladimirovna, thank you very much, and other people for the fact that I did not spend time on some technical moments concerning the defense procedure. And thank you. I would like to express my gratitude to all those who supported me during my work. The text, some work on the text, and so on. Thank you very much. And the meeting is declared closed. Thank you all for participation. And Professor Cotton, thank you very much for participation. And you see the time difference is clear, and you had to get up early in order to take part in our board meeting. Thank you very much.
You're welcome. Thank you.
The meeting is declared closed.